Hello everyone, welcome to my YouTube channel. Today lesson is Queuestack. Firstly, you know about what is queue and stack. I will teach firstly what is queue. A queue is a collection of items that follows the first in first out principle. This means the first items added to the queue is the first one to be removed, similar to a line at a store where the first persons to get in line is the first to be served. The elements are inserted and deleted in a FIFO manner. First in, first out is a principles of a queue. Looking at this diagram, we can get a small idea about what is queue. Real life, we can met queue in some situations. First example, first person in the lines gets served first. Second example, first car in the line gets served first. Operations of a queue. First one in queue, enter element in queue. Second DQ, remove element in queue. Third peak, the first inserted element. Fourth is empty, check if the queue is empty. Fifth, delete queue, delete the queue. Six is full, check the FIFO queue is full. What is stack? A stack is a collection of items that follow the last in first out principle. This means the last items added to the stack is the first one to be removed, like a stack of plates where you take the top of plate first. The elements are inserted and deleted in LIFO manner. Last in, first out is principles of a stack. Looking at this diagram, you can get a small idea about what is stack. Real life, we met stuck in some situations. First example, last book placed is the first to be removed. Second, last glasses placed is the first to be removed. Operations of a stack: first push enter element into a stack. Second, pop remove element into a stack. Third, p get the value of top element without removing it. Fourth is empty. Check if stack is empty. Fifth, delete stack. Delete the stack. Six is full. Check the stack is full. Seven, top. Access the top item. What? Now let's uh, teaching what is Queuestack. A queue-stack is a data structures that combine the concept of queue and a stack. It typically follows the queue's FIFO principles for NQ and DQ element, but may implement stack-like operations for adding or removing items. The exact structures and behaviors can vary depending on the specific implementations or use case. So we using for three steps to build this. First one, the new element is enqueue to the push queue. Second one, all the element in the pop queue are put into push queue. Third one, swap the names of pop and push queue. Now let's look queue stack in a diagram. This diagram represents the process of pushing and popping element in a stack, but with the additional queue-friendly approach, it has three main sections. First, the standard stack operation. Second, a push-friendly stack. Third, a pop-friendly stack. Now look at first row. This is the standard uh, stack operation. So first stack is empty. Now push 3. The top element is 3. Now push 5. the stack 3 and 5, 5 is the top element, then push 7, then stack is 357, top element is 7. After give a command for pop, so 7 is removing. Then push 9, so stack 359, 9 is the top element. Then give pop command, so 9 is removing. The stack 3 and 5, 5 is the top element, so give again pop command, the 5 is removing, the 5 is removing, so stack 3 is remaining, so 3 is the top element. Looking at second row, it use push friendly stack. Introduce the push friendly stack and it's working. Now let's talk about the push friendly stack. In this approach, pushing element is the main made more efficient. Instead of inserting element directly into the stack, they are first in queue in a uh, queue. Ensure they are stored in an order that make pushing easier. uh, Walk through an example in the image. First, elements are pushed into a queue one by one. When we need to pop, we move element from one structures to another until we get right order. Uh, so looking at third row, it use pop friendly step. Now introduce the pop friendly stack and its benefit. In the pop friendly stack, popping element is most efficient. Instead of popping directly from a normal stack, we use a queue based technique to make popping faster. uh, Walk through the diagram step by step. Explanations how elements move in the queue before popping occur. Before moving an element, the queue structures help adjust the order, so the topmost element can be popped instantly. This approach balances performance, making pop operations smoother. Now we moved code part of a queue stack. This code imports and class definitions. Imports, first we import linked list and queue from Java utility package. Then we define a generic classes queue stack, allowing it to store element of any type. uh, Queue and constructor, queue declarations. Inside the class we declare two queues, q1 primary queue and q2 temporary queue. The constructor initialize both queue using linked list. Push operations, explanations of push. To push an elements on the stack, we follow these steps. First, add the new element to q2. Second, transfer all element to q2. uh, Second, transfer all element from q1 to q2. Third, swap element 1 and Q2. So Q1 always contain the latest stack element. This ensure that the most recent added element stay at the front, just like in a stack. Pop operations. Explanations of a pop. The pop method remove and returns the top element of the stack. If Q1 is empty, it's throw an exception. Otherwise, it remove the front element of Q1, which is the last pushed element. LIFO. Peak operations. explanations of peak, the peak method return the top element without removing it. It check if a Q1 is removing and throw an expressions if it is, otherwise it returns the front elements of Q1. Check in if stack is full, empty. Explanations of empty method. This method simply checks if Q1 is empty and return boolean's value. String representations to explanations of a string. The method override to string method to display the elements of stack. Conclusions. In this way, we successful implement a stack using two queues. Although this method work, it is less efficient than a normal stack because pushing elements take zero n time. Now we move time complexity and applications of Queuestack. First one, storing large database due to its average 0 n log n time complexity. Sort is often used in scenario where sorting large amount of data is required. Second, database query optimizers. It is used for sorting data in relational database to speed up search queries. Third, computer graphics. Quickshots can be used for storing geometric data or pi- uh, pieces values efficiently. Fourth, in memory sorting, it is popular choices for in memory sortings due to its efficiency and small stack space required. So partitions. Quicksort partitions method is useful in some algorithms that require divider data sets into small subset, such as in finding the kth smallest largest element. If you found these explanations helpful, please like, share, and subscribe. See you in the next video. Thank you for watching for me.